Right, so here we've got our example. If the current flowing through a coil of inductance of 0.5 henries increases from 0.5 amps to 8 amps in 30 milliseconds, calculate the average value of an induced EMF. So we go straight to our equation. E equals minus L, that's our inductance, times the larger current minus the smaller current divided by the time taken. Okay, don't worry about this minus sign, that will just sit there throughout the equation and we'll end up with a minus voltage at the end, and that just indicates a back EMF. So the first step is to identify what these numbers are with relation to the letters in our formula. So first of all, we've got 0.5 henries. Henries is our inductance, and that's our L in our equation. Then we've got our two currents. Our first current, the smaller one, that's our I1. And our second current, our I2, is 8 amps. And that all happens in a time frame of 30 milliseconds. So milli, that tells us it's times 10 to the minus 3. And we need to bounce our decimal point 3 places to the left. And this is going to give us an easier number in our equation. So back to our formula. We're keeping that minus sign there. And now we need our L, which is our 0.5. And that multiplies by our I2 minus our I1. And that's all divided by our time of 0.03 seconds. Okay. Now just to take that a step further, a bit more simplified there. And you can put that all into your calculator, and that will give you an answer of minus 125 volts. And that is your induced EMF.